Thank you very much, and thank you very much for the invitation. So, quantum computing. As we all know, digital computers have really changed any aspects of our daily life, right? Well, the arrival of quantum computers could be even more historic than that. I'm talking here about a revolution, a computer revolution, and this revolution has the potential to change everything, right? How we are interacting with the universe, how we are solving problems, and it will also change how our economy. And this is a huge thing. And today I'm more than happy to present you what is around the topic and how you can combine it also with classical AI, because we strongly believe this is the next big thing for AI, that we are seeing more and more applications that are moving to a quantum computer. So, quantum computing in 10 minutes, it's quite tough, yeah? I will try it, at least. So, first of all, this is super interesting. Quantum computing is the first technology that takes the idea serious that we are living in a parallel universe. So, take a look into this room here. We are all forming a configuration, right? As we are sitting here. So if you are following quantum mechanics, we are sitting here in different arrangements, in different worlds at the same time. And this kind of concept we are using for building new computers and building new applications. So this is the theory. What we can do actually in practice with this is a small example. So imagine you have 1 million drawers. And I put a single item in one of the drawers. How many steps do you need to identify or find this item? On average, 500,000 steps. Well, with quantum computing, you just need 1,000 steps. Yeah? And this should be actually an animation, but what you can see here is at the end that you can use this kind of superpower also for route optimization. You can really calculate different kind of paths at the same time to find a more efficient solution. And these kind of optimization solutions we are already doing with companies like Hermes, a big logistic company from Germany. They are interested in optimizing their routes for their vehicles and delivering packages for their customers. Yeah? So it's already happening right now. And this is why we as QuantumBasel, and this is the image from our campus, close to the city of Basel in Switzerland. So one of the most exciting projects, I would say, in Europe, because we are hosting there a quantum computer. We have also access to, I would say, every quantum computer from D-Wave, IonQ, etc. We have our own AI cluster. And the long-term goal for this campus will be to win the Nobel Prize. Yeah. And this is why we as QuantumBasel exploring really the intersection between quantum and AI. So this presentation should also go into the field what we can do with this technology. And at least from my perspective, also with the background from IBM, I can say there are a lot of projects that are still failing. And this is a study from McKinsey that is actually highlighting that roughly 85% of all the AI projects that we are having are failing. And most of the time, the problem is not the technology. It's most of the time that we are using the wrong use cases. Yeah? So right now, there's a big hype that everyone is chatting with his documents or is writing emails with Copilot, and companies spending a lot of money for this kind of application. But I can say the business value behind that is quite small. So another idea it could be that there are a lot of estimations that time series has a 2 times higher return on investment for AI applications. And time series is happening everywhere. From it's data that's coming from machines, from production lines, from cars, etc. So this is a large use case, And what you can do now with quantum computing in the field of AI and time series, this is probably one of the most important illustrations. This was a research done by IBM. And this highlights actually that quantum computing can uncover unseen patterns. For example, this is a use case from IBM where they trained 2 different AI models. One classical AI model and one quantum AI model for a fraud detection use case. And the blue dots are authentic transaction and the red ones are frauds. So, and both models perform in the same way in terms of accuracy. And when we would assume that both systems are seeing the same patterns, then all dots should be on this line. But this is not the case here. And this is a strong sign that at the end, quantum computing in the field of AI can uncover unseen patterns that classical computers can't see. And this is why you have a big potential adding this kind of quantum solution into your classical AI pipeline can bring you the next performance boost. Another thing, one of the biggest problems that we are facing, right, is robustness around AI. At the end, robustness means when the input data is really different to the training data of an AI model, most of our AI models will fail, especially in time series. This is a concept that we are calling data drift. There's also other drifts in the data, but this makes it really hard for machine learning models to perform well. And also here, you can see that there is, at the end, great potential for quantum computing to overcome the limitations that we are seeing right now with AI. Oh, interesting. Actually, this should be some lines that are connected, because what you can see is now a solution, a hybrid solution, because we as QuantumBasel are thinking that the first quantum advantage will be hybrid. So we are combining classical AI with quantum algorithm. What you can see here is a meta-learning approach. A meta-learning approach is actually perfect for time series data. So it takes the prediction of different AI models, combines them in order to outperform any single model. And what we have done here, we put in another model, a quantum model, in order to perform much better. And as you can see, we trained these AI for different kind of use cases, from Hermes, Vista, and they're a great performance boost. And we did it also for energy trading. So this is a good thing, how you can combine today already quantum computing with classical AI. Yeah, and the use cases ranging from precision medicine, for energy trading, etc., because you can imagine when you have time series, you can apply these kind of models to any kind of use cases. Yeah, and this is again our campus. So our job is also to make the campus more visible for you. So check out our website. My colleague Sonja is also here. If you want to have a chat around quantum mechanics or use cases with quantum AI, please feel free, because I think 10 minutes are not enough for that. And with this, thank you very much for your attention. And then I'm looking forward to a coffee break with you.